Hello everyone, my name is Aline Malaewy. Today I'll be presenting the topic artificial breeding, the potential and challenge for the black-suited fly industry. The domestication of plants and animals were what made possible the agricultural development and to which this state we know. Most of the advances were based on empirical research. After the development of a few strains of domesticating plants, farmers started to input a controlled amount of enzymes aiming for an expected result for harvest. The utilization of animals helped to expand the production, and later on, the machinery reduced the variability caused in the past by human error. Lastly, the automation, which includes the use of IoT systems for operational almost no human intervention on the process that before requires intensive labor. Moreover, automation allows massive gathering of data that helps to improve the system over time. However, when it comes to intensive agriculture and capital operations, the traditional farming does not include all the steps mentioned before. More specifically, insect mass breeding, the current insect mass breeding systems, when compared with the current methods for food production, has a final product far being expensive compared to meat with the great need for manual and little use of automation. In summary, in most of the situations, no precise diet is used, no control of calibrating conditions. The decisions are, based on empirical research and process depending on human labor heavily. On the other hand, if you industrial enterprises incorporate the concept of mass breeding, which includes precise diets based on expected outputs, controlled or calibrated abiotic conditions, decisions based on well-established research protocols, and automated process with minimal human intervention. A good example of what I just mentioned can be demonstrated by the milk industry. Using machine learning algorithms to interpret data collection, sensor installed in the environment and on the animal, it creates a model for optimal growth conditions and potentially reducing costs. Thus, technology advances are necessary to scale the production of insects to a place where it could compete with existing sources of food and the technology applied to those industries. Now moving to the start of insect mass breeding industry, the black-suited flies. A massive amount of data has been discovered by the research community regarding some aspects of the biology, such as life cycle, and focus more on the immature phase of this fly, optimal substrate temperature, nutritional requirement that guarantees successful development from larvae to adult, and also physiology, morphology, and behavior of the immatures. However, there are a couple of information that we assume that we know in its totality. One of them is hydrothermal preference. So this information will be available to the research community and the industry probably in the next couple of weeks. But what I'm going to show here to you is within the reproductive phase, which is for 24 and 48 hours, those flies within sex has a very distinct and temperature preference. And this might help us to guarantee best optimal conditions for those flies within the lacking arenas inside of the artificial breeding. However, we do not know what will be the maximum and minimal tolerance per sex in this fly. This is important, and I will mention here, according with this paper conducted with Rudolph Suzuki. If you see on the right, those are ovarian on the top and testicle on the bottom of flies that were heat stressed. compared with healthy flies on your right, the reproductive capability of these flies were diminished based on the heat stress in the wind. A second point is the individual and group thermal preference. Most of the data are conducted do not distinct what would be the thermal preference individually or as a group. The third point would be the sample size. It's important to mention that most of the information published by the research community uses subsample of island bread populations. It's extremely important that this data gets multiplied the same methodology across populations in different geographic locations. And also the sexual status of the fly must be taken into account. Mated males and females would have a different physiological response in terms of thermal preference compared with pregnant males and pregnant females. So pregnant females and pregnant females and virgin males and females. Regarding to the sex-specific nutrition requirement, a very recent paper published by Barranca Fonseca a couple weeks ago showed that the protein and carb ratio would impact the adult weight. And we know that adult weight is possibly correlated with fertility and fertility. Also, we know that males, recently emerged males, will come with full load of mature sperm, which tells us that all the research or all the resource allocation invested towards to sperm production happens during the immature phase. Therefore, studies focus on the protein carbs content for males and for females, as well as micronutrients should be focused on the industry in the next following years. Epigenetics also must be taken into account when developing sex-specific nutritional diets. A third point that I'd like to bring is the life cycle process, such as incubation, innate, harvest, nursery, and go out. We do know that the larvae will have a different metabolic state throughout the immature feeding stage, going from a catabolic to an anabolic phase. It has a huge impact on the amount of heat that those flies will release throughout the development, and this will impact on how those factories should be designed to accommodate that. Anyway, abiotic parameters from nursery, as well as abiotic parameters from egg incubation, are points that has not been covered by the research community, either by the industry, as I am concerned. Another point important to mention is the variation within the systems within this process. So for instance, the neonate weight, as most of the BSF readers know, the neonate weight will change through within the population and throughout the batches. How to minimize that and take account for this, minimize the financial loss. It's also a point that has to be included as a research for the next 4 years. And reproductive physiology, morphology of the behavior. I can stress more that there is not enough data on that. And we have a common knowledge that males and females at the same age would reach the best reproductive output. However, we don't have a baseline since no information is being released on wild populations. So we don't know how far we can go and how much manipulate use molecular tools. Another point is those methods, as I mentioned for the other topics, must be replicated in other populations from other geographic locations. And we should also associate the impact on diet of treatments. As the main challenge that I see for the industry overall is characterized 3 main points. One is the business model. Everything has a cost. So as much as you wanted to have your system work as perfect as possible, be aware that cost-effective process are better than just reach the stars. Long-term R&D data is never enough. As I mentioned in the previous slide, most of the data available are made by academics, and they use a very well-established setup of samples and methods, and this might not apply for your reality. And the third point is automation. Repeatability with minimal error is everything. So making sure that every single process is being monitored, and you can get data from all this process in order to fix possible mistakes and improve this process over time. The possibilities within the BSF industry are infinite, especially with R&Ds, with multidisciplinary teams composed by biologists, nutrition, and engineers. Those focus on physics, the phenomena happening at as it goes, using instruments properly to gather this data. In a summary way, using sensors to capture data that will get analyzed for creating models that will, use algorithms to notify when something is going on or something can be changed for optimal results. What BSF industry must be doing now? Well, as nutrition technology, we are already using the concept of input data and output to improve your system. So everything that we input, such as population density, diet, micronutrients, temperature, environment, substrate, the ventilation, we know that will result in an output such as bioconversion time, the amount of ammonia, any other greenhouses that will be released, plus latitude and composition. All of those inputs, outputs will be gathered together and a feedback stream for algorithm and analysis for improvement over time. Also, as I mentioned about the business model, the importance of recognizing business model based on feasibility studies is be creative. We know that indoors might be the answer for optimal breeding of flies, but also they are very costly, and depending on the location you are playing at the industry, outdoors might be the solution. It will not be the most effective, but good enough for you to be profitable. And another point that I would like to mention is here at NT, we are taking steps to become the leaders that will put PSF as a commodity and feed input distribution within the next few years. We are doing that by creating automated process, bringing machinery to make those highly labor process with the least amount of intervention as possible, and make them repeatable and within the quality standards that the food industry requires. I would like to finish this presentation with a quote of the Nippling. He is the responsible for the stereotechnique insect, as some of you know, and I think this was still very accurate nowadays. Mass breeding of insects is still a young science. Improvements are likely to occur after further experiences and research. I would like to thank you for your attention. Any questions, comments, please email me on these two email contacts, and have a nice day.